Hello, I am Dr. Ramesh Chand. I am presenting various types of plasma found in the nature and in laboratory. Plasma can be characterized by two parameters: n, number density of the particles in the plasma, and kT, electronic temperature of the electrons present in the plasma. Plasma has a wide range of density and temperature and varies over 28 orders of magnitude from 10 to the power 6 to 10 to the power 34 per meter cube. While the temperature can vary over 7 orders from zero point 0.1 eV to 10 to the power 6 eV. The tremendous range of density can be appreciated when one realizes that air and water differ in density by only 10 to the power cube, while water and white dwarf stars are separated by only a factor of 10 to the power 5. Even neutron stars are only 10 to the power 15 times denser than water. Yet gaseous plasmas in the entire density range of 10 to the power 28 can be described by the same set of equations, since only the classical, that are non-quantum mechanical laws of physics are needed. First of all, we discuss about lab plasma. First, lab plasma is the example of gas discharges. The earliest work with plasmas was that of Langmuir, Tonks and their collaborators during 1920s. The research was inspired by the need to develop vacuum tubes that could vary large currents and therefore had to be filled with ionized gases. The research was done with weakly ionized glow discharges and positive columns, typically with the temperature of the order of 2 electron volt, and the density varies from 10 to the power 14 to 10 to the power 18 per meter cube. It was here that the shielding phenomenon was discovered. The sheath surrounding an electrode could be seen visually as a dark layer. Gas discharges are encountered nowadays in mercury rectifier, hydrogen thyratron, ignitrons, spark gaps, welding arcs, neon and fluorescent lights, and of course the lightning discharges. The another useful laboratory plasma which discuss here is controlled thermonuclear fusion. The hydrogen bomb fusion reaction is used to make a reactor under controlled condition. The principal reaction which involve deuterium and tritium produces helium nucleus and neutron with tremendous amount of energy. The cross section for fusion reaction are appreciable only for incident energies above 5 kilo electron volt. So it is necessary to create a plasma in which the thermal energies are in the 10 keV range. The problem of heating and containing such a plasma is responsible for the rapid growth of the science of plasma physics. The problem is still unsolved, and most of the active research in plasma physics is directed towards the solution of this problem. The another plasma sources found in space termed as space plasma. First is terrestrial plasma. Of course, the study of the Earth's environment is an important tool for consideration of the plasma. A continuous stream of charged particles called the solar wind impacts on the Earth's magnetosphere, which shields us from outer radiation and is distorted by it in the process. Typical parameters for the solar wind are the number density 5 into 10 to the power 6 per meter cube, ion temperature is about 10 eV, electron temperature is about 50 eV, magnetic field is around 5 into 10 to the power minus 9 Tesla, and the drift velocity is 300 km per second. The ionosphere, extending from an altitude of 50 km to the 10 times of Earth radius, is populated by a weakly ionized plasma with density varying with altitude up to 10 to the power 12 per meter cube. The temperature is only about 10 to the power minus 1 electron volt. The Van Allen belts are composed of the charged particles trapped by the Earth's magnetic field with typical parameter number density 10 to the power 9 per meter cube, electron and ion temperature is about 1 electron volt with magnetic field 500 into 10 to the power minus 9 Tesla. In addition, there is a hot component with 10 to the power q per meter cube of number density and 40 keV electronic temperature. The normal component have a electronic temperature about 1 eV while the hot component have the electronic temperature about 40 keV. So that component is called as hot component. Stellar interiors and atmospheres are hot enough to be in the plasma state. The temperature at the core of Sun is estimated to be 20 kilo electron volt, where the thermonuclear reactions occurring, which is at this temperature, are responsible for Sun's radiation. The solar corona is a tenuous plasma with temperatures up to 200 electron volt. The interstellar medium contains ionized hydrogen with number density 10 to the power 6 per meter cube. Various plasma theories have been used to explain the acceleration of cosmic rays. Although the stars in a galaxy are not charged, they behave like particles in a plasma, and plasma kinetic theory has been used to predict the development of galaxies. The Crab Nebula is a rich source of plasma phenomena because it is known to contain a magnetic field. It also contains a visual pulsar. Current theories of pulsars picture them as rapidly rotating neutron stars with plasmas emitting synchrotron radiation from the surface. Most of the content of this video is borrowed from the book Introduction to Plasma Physics and Controlled Fusion by F. Chand. For teaching purpose only during this pandemic situation. Now I am ending this video here. Thank you.